it's great to be over here. Tonight I'm going to be speaking about Vaadin, surprise, surprise, and a bit of about Google Web Toolkit, or how you should say probably GUI today, as they kind of dropped Google from the name. Who has been using Vaadin? Anyone? One user. Anybody has tried out the demos or? Okay, so I have a bit of a mission today. Convince you. So how about the GUI? Have you been using GUI? One guy. So Vaadin, we kind of started from Finland, and most of the team, around 70 guys at the moment, are in Finland. And surprise, surprise, Vaadin is a word that means reindeer, or female reindeer in Finnish. I did a really academic kind of market study at the pub in London, asking if people can pronounce Vaadin, and it seemed that guys from US, guys from UK, guys from India, everybody can pronounce Vaadin as Vaadin, and it turned out that then guys from India are saying Vaadin, and the US guys are saying something else. And at one meeting at Google, we were kind of trying to get Google Glass to actually recognize the word Vaadin, and we failed miserably. Nobody in the room could actually pronounce it correctly. So if anybody knows how to pronounce Vaadin, that would be good. I mean, with the US accent. Really, it's a UI library for building rich web UIs. The kind of focus is in rich desktop-like UIs in a way that if you have been building something in Swing or Visual Basic or any of those component-based libraries, you will feel just home with Vaadin. So we kind of ship a lot of UI components. It's like building UI out of Legos, like high-level Legos, like trees and buttons and so forth. But the philosophy is a bit different from many other web frameworks. So we are focusing on two different things. We are focusing in rich user experience as well as developer productivity. So our kind of key goal is to minimize the number of code lines in your application in the UI layer so that you can really be super productive when you're building the UI. And we are doing some sacrifices when we are having these kind of targets. But these are the targets anyways. The way how we do this is basically we kind of hide HTML behind Java. So we kind of put high-level Java APIs on top of HTML platform and bridge those two platforms and make it much, much more productive to build web UIs directly in Java. And many guys are asking, why on earth you are doing this? HTML5 is so nice platform and everybody knows it. But when you're kind of taking a look at these modern web applications, most of these are actually consumer-oriented, or many of these are consumer-oriented. And people, when they are using these nice web apps, they kind of start to kind of learn that web apps can be super rich. And then they go back to work and use enterprise apps. And they expect similar kind of UIs as from the consumer apps. And what they get is actually pretty much this. And then it's sad. I mean, this looks horrible, and this is how people are building their UIs in the enterprises. And my kind of one thought, why is that? Is the reason that the consumer apps, they are having like millions of users, and the enterprise apps are having really few users, like tens of hundreds of users. And at the same time, consumer apps are pretty small. They don't have that many views. If you think about Facebook, how many pages are over there? I mean, like different kind of pages. But any kind of ERP system, it has like tens and tens of views and a lot of logic behind those views. So you kind of, even though you want to put a higher price tag for an enterprise application, you end up in a situation that the guys building those consumer apps, they can actually invest tons more in those few views than the guys who are building enterprise applications. They basically are expected to ship really nice UIs with really low budgets. And this is a bit of a problem that we try to solve. So how to do it? We basically build this on top of three ideas. So the first one is that everything in Vaadin is a component. I mean, we have UI components, we have data source components, we have themes. So all of these are modular, all of these are packageable, all of these are shippable to other developers. So let's start from the UI components. I'll show you a demo, it's easier that way. Who has seen the demo? No one. Great. Let's see if this works.
Is the line okay for everybody?
I think so.
So basically this is like kitchen sink for Vaadin. You can kind of browse through features, see what kind of features are over there, take a look at different UI components. This is a Vaadin UI, of course. It's a pretty untypical Vaadin UI though, so it's more like game PS3 type of UI. But anyways, let's take some simple component like date picker component. And just going to showcase what happens if I choose a date from here and want to show some kind of notification over here. How do I do this? Let's show some source code. So you can actually kind of try out user interactions and then take a look at the source code and kind of learn how this is programmed. I'm not going to go into the source code yet. And you can also try out different properties for this. So let's see if we want to put the locale to be, let's see, Chinese, how the component behaves in this case. So we clearly get Chinese locale over here. So we can try through different components, maybe a bit more rich calendar component, or we could go in the, let's say, charting components. Those are always nice. Add-on section. So you can try out different kind of charts and find a chart that you like in Vaadin and start to use those in your project. And start cut and paste the code and kind of learn from there. In the kind of core, there are around 100 or so UI components. Yeah, I'll show this one live as well. So that was more of a, I would say, untypical Vaadin application. Let's take a typical one. There is something wrong with my web browser, but maybe want to restart this one. Oh yeah, nothing really wrong as it. Even took a while to close. So let's show another example. This is more of a, I would say, typical Vaadin application. You occupy the whole screen, not like web-like layout, more like a desktop-like layout. You sign into the application. You might have like a lot of components on the screen. Maybe show some interactive graphics over here. Typically, this is used for like boring business applications, like insurance, banking, any kind of in-house application where you might have like tons and tons of data. And building things like long list is super easy. You just put a Vaadin table component on the screen, connect that to a data source, and then you start showing data from there. So everything that you see on the screen is actually built in Java. There is no bit of JavaScript, no HTML whatsoever to write. And you can still do pretty interactive UIs like, let's see, we can build drag and drop UIs or quite complicated layouts and so forth. So these are like really rich interactive applications. The same applications, because this is just on the rendering side, it's just pure HTML. So the same application actually runs just fine on iPad or iPhone or Android devices. The thing is that if you try to run the same application on an iPhone, even though it runs, it's pretty much unusable because of the small screen. So you should take into account the screen size. But for that, there is also mobile library for mobile components that look and behave like native components. And we basically support all the web browsers out there. So at the moment, Vaadin 7 version that is like the newest stable version out there. It supports everything since IE 8. If you really want to support even older browsers, Vaadin 6 is supported as well and support even IE 6 and 7. But don't go there, it is pretty painful. Thing is that even though we have like quite a lot of components in the core, like 100 or so UI components, most of the components are written by the community and they are outside of the core. So we have this directory of add-on components, and at the moment there are over 400 add-on components. Some of these are like UI components, some are data sources, some are component libraries, so it's pretty hard to actually count how many UI components there are. In the directory, actually this is a pretty good case why you don't want to put all of the UI components in the front core. So, for example, this component, paper stack, it's layouting component where you can put your UI components in a sticky notes. I mean, this yellow one is a sticky note and the gray one is a sticky note, and all of these are just UI components. And then you can tear the pages out of the sticky notes. And even though it's a fun component, it's pretty much like there is no reason for such a component. But at the same time, it's kind of demonstrates that it's pretty good to have strong packaging mechanism for shipping those components. It looks simple, it's really simple to use. Here is pretty much the whole example in Java code. You take a component that like labels inside of it and whatnot. But the thing is that in order to render this in a real web browser, you have to do really funky tricks like calculate the shadows on a transparent canvas, duplicate the DOM 10 times in order to kind of somehow reveal components in a diagonal fashion and do that kind of magic behind the scenes. So that way, if you happen to have one of those HTML5 JavaScript wizards in your team, he can be the one who actually builds those components, packages these, and then the rest of the team can just use the Java APIs like this. To use these, you just cut and paste POM definition to or payment definition to your POM file, and it pretty much integrates itself from there. Or you can actually download this as a jar file and drop that into a project. Who's using Maven, by the way? What the heck the rest of you are using?
Gradle.
Gradle. Oh, that's a good choice. To me, it kind of starts out that Maven has pretty much took the whole market share, but Gradle is still, it's a better solution, so there is a reason for it to be over there.
Also use Ivy sometimes.
Yeah, and we actually use Ivy pretty much out of the box with Eclipse plugin, so it doesn't do so much, it just downloads the dependencies, but it does pretty.
That's all I ever
yeah.
wanted out of it.
That's true.
It is getting sense.
So those were the UI components. Then themes. We ship with a couple of themes. This is, I would say, the default theme called Reindeer. Surprise, surprise. It's pretty good for those boring business applications. So it doesn't look anything spectacular. There is also a bit more fancy theme called Runo in the package, and also a theme that you can customize, basically cut them, pick the colors, and then it generates the basic theme for you, and then you can customize it with CSS. All the themes are just CSS. Or you can go like fully customized and just override all the look and feel. So, for example, if I have this example over there, I do. So this is just standard Vaadin components and some theming on top of that. And if I recall correctly, this application is like 300, 400 lines of Java code plus some theming. So you can kind of customize the look as you wish. Data sources. When we started this project that was already year 2000, we had a bit of a problem to kind of decide how we are going to be doing data sources for UI components. So there was this pretty dominant Visual Basic 6 model where you just put the data inside the components. And it was a kind of really understandable, dumb way of doing that. But we thought that, hey, we should be smarter. We used the Delphi model and kind of put data sources to all components. And we actually implemented both of these. And for the dumb model, we can notice that it's too limiting. For the data source model, we can notice that if you want to do something simple, like put that option group with 3 different options on the screen, it's pretty heavy to ask you to build data sources. So we kind of ended up in a situation that all UI components, they both implement data source support as well as built-in data. And the data model is pretty simple. We have properties, so this is just one value. We have item, that's basically object, set of named properties, and then we have a container, it's like a set of named items. So this can be like tabular data or hierarchical data, and actually there are quite a few like sub-interfaces for these if you want to implement these. And all of these are actually simple Java interfaces, so you can implement any of these data models and connect these to any UI component. There is also quite a few implementations in there, so in most cases you don't even have to implement anything by yourself. You can take like JPA container and just bind directly to JPA beans, and that's it. So that was the first thing, kind of pillar of Vaadin. The second kind of thing that we are building on is quite unique server-client model. So if you're building a rich web application, it basically means that you always have these layers. You are building a UI in JavaScript. You have some kind of communication layer that might be like REST or so or whatever you might have over there. On the server side, you must have some kind of web server that sends the initial web page at least, and JavaScript files and so forth. And almost always you have a separate backend server, at least a database somewhere. And if you're building this in JavaScript, you pretty much have to implement all of these layers. So you have to implement the JavaScript-based UI, communication, web server, and so forth. And over here, you should be using JavaScript as a language. For the communication, it's like JSON or XML or something like that. Web server, whatever you choose. Backend, whatever you choose. Then Google came out with a solution called GWT, and the key innovation over here was a really great Java to JavaScript compiler. So you basically can compile Java language directly to JavaScript, and this kind of makes possible for you to actually choose which language you are using on the UI side. So you can use either language, but you still pretty much have to implement all of these layers. You optionally can do some JavaScript. In Vaadin, it's a bit different. You only have to implement server-side layers, backend and the web server. Rest is totally optional. I mean, if you don't implement these are generated for you automatically. So all of this is automated, but at the same time, even though we abstract away from HTML, we leave the possibility for you to actually implement any of these layers by yourself, or part of these layers by yourself. So you have the full control over the parts that you want to control, but you don't have to do it. And because everything has to have a backend, we can actually just compare the UI layers. So it's like 1 to 3. And with this kind of 1 to 3 comparison, it's pretty obvious that the amount of code that you are going to be writing is quite a bit smaller if you are just writing 1 layer instead of 3. So you save a lot in code lines directly, as well as maintaining these and so forth. Of course, this is a compromise. If you are using automated implementation of these, you don't have control over what happens over there. So you kind of leave things to the framework to do. So how does it work actually?
Where would you see AngularJS, for example, in this picture?
Oh, it's clearly over here in JavaScript. So over there you're using client-side MVC model to actually implement the UIs. But you still have to do the communications. You have to publish APIs to web. You have to build the server side to communicate with. So
But
So-
the framework is implemented in Angular as well, right? You have your framework built in basically
Yeah,
to communicate to the server. So.
yeah, that's true. So basically there are really handy ways of crafting Ajax calls back to the server side, right? But the thing over here in the communication layer is that you actually have to design it. You have to decide that, hey, I want to open up this RESTful service for, let's say, loading addresses, my address book and deleting addresses and so forth. So you have to kind of design these, you have to implement and open these to the web, and you have to make these secure. Whereas in over here, if you are not implementing anything on these layers, it's pretty much automated, so you don't have to kind of even think of it. You can use the backend directly from the UI.
So what actually runs in Vaadin on in your browser? I mean,
I'll go over there. So let me show you. So if this is a kind of super simple Vaadin UI. You create a text field and a button, and then you start listening for the clicks from the button. Of course, because we support Java 8, I should probably write lambda over there, but with lambda that would be just E, arrow, and notification show. So that would be one liner. But anyways, this piece of Java code, this is actually run on the server side. This is not sent to the client side at all. And when you go with the web browser to a Vaadin application page, what happens is that you load bunch of HTML and JavaScript and CSS, of course, because browser doesn't know anything else. And this is actually quite heavy package. It's like 1 meg of stuff. But luckily it gets compressed down to around 100K or 200K or even 300K. It depends on how many Vaadin UI components you are using. But the thing is that the size of this payload, it basically depends on how many different body UI components you are using, not how many views you have in your application. Whereas if you would be building the thing on the client side, you would be implementing things on the client side, meaning that you would actually send the code for all those views to the client side. Okay, so when you have this, next thing that happens, we render those components on the screen. And if I interact with these components, I write my name over there and click a button. What happens is that we send an Ajax call over the wire, and in this Ajax call, we send these parameters that what have changed. Nothing spectacular over there. Thing is that Vaadin handles this and routes this directly to your code on the server side. So you actually receive this button click event on the server side Java, and you can react into that. You can change the UI dynamically as you wish, like show notification over here. And what happens is that with the response of this same Ajax call, Vaadin kind of sends modifications to this screen. It analyzes what have changed in your component tree on the server side, and it notifies that, hey, this notification box is over there, and it sends this kind of description of this notification box to the browser. This is not HTML. This is just a JSON encoded description of how to modify the UI, like, hey, please put the tree on the left and table on the right. So this is quite chatty in a way. Many UI interactions go back to the server side, but those are super lightweight, so we are just speaking about some hundreds of bytes, not like hundreds of kilobytes. Maybe I show that in practice because it kind of makes it the benefits quite a bit more understandable. So let's take Eclipse and create a new project. Vaadin 7 project, let's call it SDJAC. And we can deploy this on any kind of Java server, like Tomcat over there, or we could deploy that as a portlet in the Java portal, or the Google App Engine or most cloud providers. Let's just use Tomcat and servlets.
Is this like GWT where you work in development mode? Or
No, this is very different from GWT in this phase. So we'll go into GWT a bit later on. So what I create over there is So what we have in our project is basically empty web-inf library. There is nothing over there. Empty libraries. We could create a theme over here, but we don't have to. So the only thing that actually gets created over here is one Java file. So there is no HTML, no JavaScript, nothing like that. The Java file itself is pretty simple. So we say that, hey, we want to, when we are initting this user interface, this is the user interface that shows on the screen. We want to put something on the screen, and then we want to create the servlet that serves this UI. Maybe I'll run it to show how it works. I tend to use JRebel for making modifications a bit faster. You don't have to use it, but it's pretty handy. I guess I have an idea running at the same time over here in the background. Maybe I have some extra tomcats over here. I don't. That's strange. Wow. I should have a demo effect on this kind of thing.
Can you change the port number?
I'll just shut down the IDEs just to make sure that they don't. Yeah, there's something more strange going on with my computer. So let's restart the Eclipse. Sorry about that. That's what you get if you are not kind of booting your machine at all. So let's try it again. Okay, now it's working. Out of memory or something. I've never seen anything like that. C files. Hey, why not have a piece of pizza at this phase? I will start to go home mashing because it seems that something is really horribly wrong over here.
Or you could buy a raffle ticket.
Intermission.